Hey everybody, let's just go over the ideas on the Introductions to Functions version 3. I'm going to kind of treat this as an answer document for this, but if you're just watching it and you're someone who doesn't have this document in front of you, it's just a way of analyzing and predicting functions and understanding the relationships that exist within them. So if we're looking at this situation here, what is a function? Remember, a function means that there's a relationship between input and output, okay, where the input is the independent variable and the output is the dependent variable. And so you put something in, something mathematically happens to it, and then it generates this output, the dependent variable. So for example, you could pick any rule you want. I'm going to pick a really simple linear function. So I said, for example, y equals 3x plus 2. Basically, any input that we put in is going to get multiplied by 3, and then we're going to add 2 to it. And then it's going to spit out the output. So in this case, if you had an input of 0, right, the value would be 2, because 0 times 3 is 0, and 0 plus 2 is 2. If you had an input of 1, the output would be 3 plus 2, which is 5. If you had an input of 2, the output would be 6 plus 2, which is 8, and so on and so forth. And if the input of 3, output would be 9 plus 2, which is 11. This is a linear function. It is a function that has a constant rate. So as you increase x by 1, you're increasing the y by 3. That's why the multiplier is 3. We call that the slope. And then you're adding a plus 2, basically because this function is not proportional. If it's proportional, it's be y equals 3x, right? You're adding that plus 2 to show that you've taken this line and you've shifted it up from the origin 2 units on the y-axis. So it crosses the y-axis at 0, 2. We call that the y-intercept. So in this type of rule here, the multiplier to the input is going to be called the slope. And this is the form y equals mx plus b, where the multiplier of x is the slope, or the growth rate. And then the value that is being added or subtracted is basically going to be the y-intercept, right? Which is the place where the line crosses the y-axis. And this is a general way you'll always see anything that's a non-proportional linear function. It's always in the form y equals mx plus b, where m is the slope and b is the y-intercept, okay? So this is just one example of a function. This is a non-proportional linear function. Throughout this assignment, you're basically given mystery boxes, right? Where you don't know what the relationship between input and output is, and you've got to figure it out like you're a detective. The way that you're going to do this is very simple. You're first going to ask yourself, is it a proportional relationship? Proportional relationships are the easiest because the ratio of y over x just stays the same. It's just y equals kx, something times the input equals the output, always. So what would you multiply a 1 by to get 11? Well, 1 times 11 is 11. Is 2 times 11 19? No. So we know that this is not proportional. So this would be non-proportional for this first one. Okay, and then we're going to ask, is it linear? Now, to investigate whether it's linear, we just look to see if it has a constant slope. Now, the slope is always the ratio, change in y over change in x. It's the growth of the line. So as the input changes, does the output always change in the same way? So basically, we look at the relationship here. We go from 11 to 19. What's the change in the y? You're adding 8. What's the change in the x? It corresponds to that. You're adding 1. So the growth ratio at that moment would be 8 over 1. Let's see if it stays constant. If it does, it's a linear function. From 19 to 27, what are you going to add 19 to get 27? Right? If you add 8 to 19, you're going to get 27. If you add 1 to 2, you're going to get 3. So that ratio of growth is once again 8 over 1. So you'll notice that the slope is staying constant at 8 over 1, which means the slope is 8. Which means that the multiplier in the equation is going to be 8, and it is going to be a linear function. So y equals 8x is the place you start with. Now, once I understand that that's going to be the place I start, I got to figure out what the adjustment is. Is the y-intercept something we add on, or is it something that we're basically removing, right? Is this line shifted up, or is this line shifted down? So we're going to take a look and test it out. 1 times 8 is 8. What would you add to 8 to get 11? You have to add 3. So if we have the rule correct now, it looks like it crosses the y-axis at 0, 3, and it looks like it has a slope of 8, up 8 every time it goes over to the right 1. Okay, so let's investigate and see if this works. 2 times 8 is 16, plus 3 is 19, works there. 3 times 8 is 24, plus 3 is 27, it works there. So it works for every value in the table, so that means 4 times 8 is 32, plus 3 is 35. This must be 35. And so now we can accurately say this is not just non-proportional, this is a non-proportional linear, because it has a constant rate of growth, right? The slope is 8. And it is a function. Now, why is it called a function? Because they're applying this rule, right? There's an independent variable, a dependent variable that are related by this rule. And for every input, there is only one expected output. If it's a function, for every x, there is only one corresponding y. So every time you put a 1 in, you're going to get an 11 out in this case. Every time you put a 1 in. So the next time you put a 1 in, you should still get 11 out. Okay, that's how you do it. Let's do the next one. So on the next problem here, we're going to go through the process again. First thing, is it proportional? Well, I can see here that 4 times 1 would be 4. So is 0 times 1 3? No. So right then and there, I can say it's non-proportional. So we know this is non-proportional, so that's the first thing we would write in our description. The next thing we're going to figure out is it linear? Well, if it's linear, then there should be a constant rate of growth, constant slope. As x increases by 1, y always increases the same way. So what's the change in the y? Plus 1. What's the change in the x? Plus 4. What's the change in the y? Plus 1. What's the change in the x? Plus 4. It looks like the ratio of growth is always 1 to 4, or 1 over 4. So the slope ratio, change in y over change in x, is going to be, in this case, 1/4, which means your multiplier is 1/4 in the linear function. So we have y equals 1/4 of x. But if it was 1/4 of x, then obviously it would be negative 4 times 1/4, which would be negative 1. And it's not negative 1, is it? It's 2. So we have to figure out what adjustment was made. So negative 4 times 1/4 is negative 1. What will we add to negative 1 to make it into 2? Once again, it's adding 3. So it looks like this is the linear function rule that we're working with here. 0 times 1/4 is 0. 0 plus 3 is 3. Works. 4 times 1/4 is 1. 1 plus 3 is 4. It works. So we now know it's a function. It's working for the entire thing. And 8 times 1/4 is 2 plus 3 is 5. So now we've filled everything out. We can say that this is also a non-proportional linear function. Okay, let's go to the next one. Here you have a situation where we're given the rule. When you're given the rule, it's super easy. All you got to do is plug in. So 1 times 1/8 is 1/8. 2 times 1/8 is 1/4, which is 2/8, right, which is 1/4. 3 times 1/8 is 3/8. And then 4 times 1/8 is going to be 4/8, or 1/2. So you can see for every input, you should multiply it by 1/8 and get the output. The slope of this line is 1/8. This is a proportional linear function. So the fact that it's just multiplication, there's no addition and subtraction, means it does go through 0, 0. It's a straight line that does go through the origin. So you would call this a proportional linear function. Why is it a function once again? Because for every x, there's only one y. When you put a 1 in, you get it a 1/8 out. Every time you put a 1 in, you're going to get a 1/8 out. There's no time where you put a 1 in and get something different than 1/8. Okay, let's take a look at the next one. 0 times something is 0. That could be proportional. 1 times 7 is 7. Is 2 times 7 14? Yes. So this looks like it's a proportional relationship. So in this one, you're going to write y equals 7x, because the ratio of y over x is 7 over 1, or 7. 14 over 2 is also 7, right? So that ratio stays constant. So 3 times 7 is 21. We filled out the table. This is another example of a proportional linear function. And that's how easy that one was. Let's go to the next one. For this one here, you're going to do the check to see if it's proportional. Is 3 over 1 the same as 0 over 2? Well, no. 3 over 1 is 3, and 0 over 2 is 0. So that's not the same. So now we know this is, once again, a non-proportional relationship. And then we check to see if it's linear. So what would we add to 3 to get 0? We would add a negative 3. What would we add to 0 to get negative 3? We add a negative 3. So as the x increases by 1, it looks like the y is decreasing by 3. As the x is increasing by 1, once again, it looks like the y is decreasing by 3. That seems to be a constant slope of negative 3 over 1, or negative 3. So your multiplier is y equals negative 3 times x. So now we got to figure out what the adjustment is. So 1 times negative 3 is negative 3. Negative 3 plus something that equals 3 you'd have to add 6 to it, so it looks like a plus 6. Let's see if it works. 2 times negative 3 is negative 6. Negative 6 plus 6 is 0. It works. 3 times negative 3 is negative 9. Negative 9 plus 6 is going to be negative 3. It works. And 4 times negative 3 is negative 12. Negative 12 plus 6 is negative 6. So this is definitely a non-proportional linear, because it does have a constant slope, constant multiplier, function. Why function? Because it has one output for every input, right? Okay, let's take a look at the next one here. This one you're given the rule, so it's really easy. You just plug in. 1 times 9 is 9, minus 5 is 4. 2 times 9 is 18, minus 5 is 13. 3 times 9 is 27, minus 5 is 22. 4 times 9 is 36, minus 5 is 31. This is an example of y equals mx plus b, or a non-proportional linear function. And once again, in this form, y equals mx plus b, remember the multiplier is the slope or growth rate, change in y over change in x, and the minus 5 here is going to be where the line crosses the y-axis. So this line will cross the y-axis at negative 5, and it will grow by a slope factor of 9, which basically means as x increases by 1, y will always increase by 9. Okay, let's look at the next one. This one is giving us the rule. This is a non-proportional nonlinear function. This is an x squared. It's a parabola. And so you just plug into it. 1 squared is 1. 1 times 3 is 3. 2 squared is 4. 4 times 3 is 12. 3 squared is 9. 9 times 3 is 27. 4 squared is 16. 16 times 3 is 48. And you're just going to write non-proportional nonlinear function. Why is it non-proportional and nonlinear? Because it's an exponential, it's a parabola, it's a curve. It doesn't have a constant rate, but it's still a function because for every x value, there is only one corresponding y value. Okay, the next one is in the form y equals mx plus b, so you should start to recognize that. That is a non-proportional linear function. So you write that in, non-proportional linear function. And the slope is 1/4 and the y-intercept is 1. So you can identify the slope. You can identify the y-intercept. And we can now plug in. 0 times a fourth is 0. 0 plus 1 is 1. 4 times a fourth is 1. 1 plus 1 is 2. 8 times a fourth is 2. 2 plus 1 is 3. And then 12 times 1/4 is going to be 12/4 or 3. And 3 plus 1 is 4. And that's how you do that. On this one here, you have to ask yourself, is it proportional? 1 times 3.5 is 3.5, but is 2 times 3.5 4? And the answer is no. So then we're going to write non-proportional here. And we're going to see if it's linear. Remember, if it's linear, you have to have a constant rate. So as x increases by 1, y should be increasing in a constant way. So always at the same. So 3.5 to 4 is plus a half. As we increase the x by 1, is this increasing by a half again? Yes. So the ratio of growth seems to be 1/2 over 1, or a slope of 1/2. Okay, as x increases by 1, y increases by 2. As x increases by 1, y increases by 1/2. So that means that your multiplier is likely 1/2. So that should be anyways, if it's a linear function like that, it seems to be. So you'd have y equals 1/2 x. So 1 times a half is a half. What would you have to add to that to get the 3.5? Well, once again, you're going to have to add 3. So it looks like it's going to be y equals 1/2 x plus 3. And let's test it. 2 times a half is 1. 1 plus 3 is 4. It works. 3 times a half is 1.5. 1.5 plus 3 is 4.5. It works. And so 4 times a half is 2, and 2 plus 3 is 5. So this is a non-proportional linear function. Once again, it's linear because it has a constant rate of growth, a constant slope. Change y over change x is always the same. And it's a function because for every x, there's only one y. Okay, taking a look at this one, you'd ask yourself, what could I multiply 1 by to get negative 2? 1 times negative 2 is negative 2, right? So if it's proportional, every input times negative 2 should be the output. Negative 1 times negative 2 is 2, that's true. 0 times negative 2 is 0, that's true. 1 times negative 2 is negative 2, that's true. So 2 times negative 2 would be the answer here, which is negative 4. And we know this is going to be just times by negative 2. So y equals negative 2x. This is an example of a proportional linear function. proportional linear function. And that's a pretty easy one, right? Okay, let's go down. This one here, you're asking yourself, is it proportional? Is the ratio of output to input always the same? 1 times -2 is -2. Is 2 times -2 1? No. So this is going to be non-proportional. So you're going to write non-proportional. And then you're going to investigate, is it linear? So as y changes by 3, what is x changing by? 1. So the slope ratio looks like it would be 3 over 1, or to the right 1 and up 3. Does it consistently happen? 1 to 6 is plus 5 on the outputs. What's the input variation here? From 2 to 3, plus 1 still. So the first ratio we're looking at is a growth ratio of 3 over 1. The second ratio we're looking at is a growth ratio of 5 over 1. That's not a constant slope, is it? That ratio of growth is getting faster and faster. This is some kind of curve, right? This is some kind of non-proportional, nonlinear function. So this is nonlinear, okay? Okay, so since it's a non-proportional, nonlinear function, we've got to be a little bit of a detective here. Now, usually that means you're going to have an x squared in the function. So it's like y equals something times x squared plus or minus something. So it could have a plus, whatever. When we look at this, if we had an x value of 0, it would make it easy because we would see what the plus or minus is. We don't have an x value of 0. If I assume it's an x squared function, let's just play with the value of x squared. 1 squared is 1. What would you add to 1 to get -2? It looks like you'd add -3. So if it was just a simple x squared function like this, you'd be looking at y equals x squared minus 3. Now let's test it out and see if that is and how easy it is. 2 squared is going to be 4. 4 minus 3 is 1. That works. 3 squared is 9. 9 minus 3 is 6. That works. So that is the rule. All right, so it is a function. There's a rule that works. Input is the independent variable. Output is the dependent variable. For every input, there is only one output. And so we can see that this non-proportional nonlinear function is still a function, and it is predictable, and we can see exactly what the value here would be. So 4 squared is 16, and then 16 minus 3 is 13. So that value should be 13, and you're done with that one. And this last one, it is a non-proportional linear function. We already know what it is. We've seen it before. This is in the form y equals mx plus b, where the slope is -4 and the y-intercept is 6. So this is a non-proportional linear function. And in this case, like I said, the slope is -4. So that means as x increases by 1, y decreases by 4. And the y-intercept is 6, which means as you look at the y-axis, right, it's going to cross the y-axis at the order pair 0, 6. When x is 0, y is 6. And so we can now plug in 4 times -4 is -16. -16 plus 6 is going to be -10. And that is the last value there that's going to work. And so that's how you would do this page.